Hi, this is Amr. Hope you are all safe and sound. In this work, we are going to apply text summarization in Amharic language, the native language of the Ethiopian people. Text summarization is the NLP task of condensing a long text into just a handful of sentences containing the main concepts discussed in the given long sentence. There are two main approaches for summarization, either extractive or abstractive. In extractive approaches, statistical models select important words to be copied. However, this is limited to not being able to paraphrase sentences. So this is why in abstractive approaches, deep models are used to understand the given text to produce a summary. Data used for this task comes in a form of news articles as long text, where their titles are used as their summaries. We have built our own dataset for this task by scraping Amharic news websites, collecting around 19,000 articles. We have also trained our own word embedding model using this dataset. This task is considered as a sequence-to-sequence problem, where we build a deep model to map between the input article and the output title summary. However, there are problems that sequence-to-sequence approaches suffers from, namely vocabulary issues from using word-to-vector based models for word embedding and problems called exposure bias. Vocabulary issues comes from the fact that the model is only trained on a limited vocabulary, so unable to cope with out-of-vocabulary words, while the exposure bias comes from the fact that while training, we provide the model with the reference summary, while in testing, it is not provided. There are many models for sequence-to-sequence problems. We have selected the line of research that was researched to solve these sequence-to-sequence problems that we have just mentioned. Our model is based on sequence-to-sequence with LSTM and attention. Then we use a pointer generator model to solve the vocabulary issues. Then we add the scheduled sampling behavior to solve the exposure bias problem. Our baseline is an encoder-decoder based model where we use LSTM in both the encoder and the decoder, where the encoder builds an internal encoding of the text and passes it to the decoder to generate the output one word at a time. Then we add a pointer generator model, where we copy the unknown words to the output, as instead of resulting in unknown token, we build a neural network to learn when to generate a new word and when to copy a word from the input to the output. Then we add our scheduled sampling model, where we build our architecture to first depend on the reference words, and as the model matures, the probability of choosing the reference words decrease, and the model begins to depend on itself more, hence limiting the exposure bias problem. The score for this task is measured using rouge and blue metrics. However, the results are less than those of the English dataset. This comes from the fact that the amount of Amharic data online is limited compared to the English ones. The code for this work has been optimized to run on Google Colab and to connect to Google Drive. You can find the code on this link. We hope that by this work we are contributing to the African NLP community. Hope this has been beneficial and hope that you are all well.